like that. So, and then I'll talk about the basis of life, scientific theory, all of that kind of stuff like that. Do you have any questions on stuff chapter 1? Who's taken any of the lecture quizzes yet? So if you've done the lecture quizzes, you'll get a pretty good idea of the structure of the exams. I would strongly encourage you guys before the exam on Thursday to take the lecture quizzes for exam 1 or module 1 if you haven't already done so. It will really prepare you for the exam and give you a better idea of what you need to maybe work on if what you're stuck on. What questions do we have about chapter 1?
What's homeostasis again?
What is homeostasis, guys?
The body
Temperature?
maintains balance, sorry.
Maintains balance of what? Like, give them an example.
Everything.
Okay. Give him an example.
Is it like hormones? Like the balancing hormones?
So, like for example,
metabolism.
Right, metabolism, right? So, for example, thyroid hormone, right? Right. What happens if you have too much thyroid hormone? You would have a condition called hyperthyroidism. If you don't make enough thyroid hormone, you would have a condition called hypothyroidism, right? If you produce too much growth hormone, you have a condition called acromegaly or gigantism. What happens if you don't produce enough human growth hormone? Dwarfism, right? So, right, our body wants to be in the middle, right? We don't want to produce too much of a biochemical pathway or too little of a biochemical pathway, right? We want to be like Goldilocks and Three Bears, right? What's another name for homeostasis?
Is it metabolism?
Not metabolism. Metabolism is part of homeostasis. Equilibrium. There you go. Sure. It is what it is. Right. Do we understand, like, for example, all of these terms? Superior, inferior, anterior, posterior, medial, lateral. We didn't cover bilateral, ipsilateral, and contralateral, so let me cover that real quick. So what's bilateral, guys?
Both sides.
Both sides. What would be ipsilateral?
Neither side.
So this would be same side, and then contralateral would be like that. Yeah. So an ipsilateral reflex would be like the withdrawal reflex, right? So you've broken your arm or dislocated your shoulder. Doctor goes to look at your arm. What are you going to do? You're going to recoil away from it, right? So that's a withdrawal reflex, right? You're trying to balance. That would be an ipsilateral reflex. You're trying to balance yourself on a balance beam. That would be a contralateral.
What about superficial versus deep?
What's superficial versus deep?
Surface.
All right. So what would be so superficial versus deep in relation to using anatomical terms? So the epidermis would be superficial compared to the dermis, which would be deep in reference. Right. So everything is always in reference to something else, right? So the hands, right, are distal to the elbow. Huh? So parietal membrane would be your chest cavity. Visceral would be kind of your organs, and then pleural. So parietal would be heart. Pleural would be lung. So visceral would be heart. Pleural would be lungs, and visceral would be the rest of the organs in your cavity. There'll be like 1 or 2 questions about membranes. Don't really split that a whole lot.
Can you go over sagittal, transverse, and frontal again?
So If you were to divide the body on a sagittal plane, what would you be dividing it into?
The top and bottom.
Left to right?
Left and right. So for example, if you get a CAT scan and an MRI, right? So we get an MRI in your brain and we want to look at the right hemisphere versus the left hemisphere. That would be a sagittal view from an MRI. Transverse,
Top and
that would be top and bottom, right? So if we want to, right? So divide the brain in top and bottom, and then frontal would be
Front and
right,
back?
front of the brain versus the back of the brain. Okay. All three have useful functions from a imaging standpoint. Okay.
And what does it mean by describe two types of body region designation?
So we've got the 4 quadrants, right upper quadrant, right upper left, or the left upper quadrant, right lower quadrant, left lower quadrant, and then we've got like epigastric, hypogastric, iliac, chondriac, all that. There'll be like one question about that, so don't really sweat it a whole bunch. So chapter 1's gonna be pretty light. I mean, there's really not a whole lot in chapter 1. We didn't really cover a whole lot of chapter 1. So for chapter 1, really kind of know, so like characteristics of life, homeostasis, scientific method, stuff like that. What other questions do you have about chapter 1?
What are organisms called? I can't figure out this, but we're just curious what other kind of organisms besides the
So all the organ systems. So you know, there might be a question like which organ system is involved in locomotion? Muscular system. Which organ system pumps blood through the body? Cardiovascular. Which organ system is involved in the intake, absorption, and digestion of foods? Right. It's going to be very pretty obvious questions. So that's another thing, okay? There's no trick questions on the exam, but do read the question properly, right? So the question might be which of the following is, which is very different from which of the following is not, right? So, but there's no trick questions, so I'm not trying to trip you guys up, but do pay attention to what the question's asking. Any other questions on chapter 1? No? Okay, so chapter 2, make sure you know like the broad basics about like protons, electrons, neutrons. So like what's the charge of an electron, what's the charge of a proton, which ones have mass, which ones don't. So electrons have a negative charge, protons have a
Positive.
charge, and neutrons have no charge. Protons and neutrons have mass, electrons basically don't. Atomic number. Atomic number is the number of
Protons?
protons. Atomic weight is the total number of protons and neutrons. If you have an element that has a different atomic mass, 2 of the same element that have a different atomic mass, you call that a what? Isotope. Isotope. What's an ion? An ion is an atom that has a unequal number of protons and electrons, right? So what's a positively charged ion called?
Cation.
Cation. What's a negatively charged?
Anion?
Anion. So make sure you know the difference between the two. What is the difference between an ionic and a covalent bond? And give me an example of each.
Ionic bond is a weak bond.
Can be a strong bond.
charges of positive and negative.
Permanent transfer of electrons, right? So sodium chloride would be an example of an ionic bond, which is a relatively weak bond. Right? Covalent bond would be what? Share electrons. What's an example of a covalent bond?
H2O.
Water. There are 2 types of covalent bonds, Polar and non-polar. What would be a non-polar covalent bond? I give you a specific example in the lecture. Methane. So methane would be an example of a non-polar covalent bond. Right. So what's going on with methane? You have an equal sharing of electrons, right, versus water, which is a polar covalent bond because there's an unequal sharing of electrons. And when you have lots of polar bonds together, it increases the adhesiveness, which is what we call a hydrogen bond, right? Remember when we talked about that's why the water off the coast of San Diego is cold, but the water off the coast of Georgia is warm? Because of circulation of the current of the water. Water is very slow to heat up, very slow to cool down. It takes until October till you can't swim in the pool, but it takes until June before you can comfortably swim in it. Might as well for heat up.
Wait, how did you describe the
Hydrogen bonds. What are hydrogen bonds, guys? Lots and lots of polar bonds together, specifically between hydrogen bonds. So each individual hydrogen bond is weak, but if you have lots and lots and lots of them, right, increases adhesiveness. That's why dropping from a large depth height into waters can be lethal. There are certain types of insects that can walk on water, water bugs. They actually can use the surface tension to stand. So, what is the difference between a molecule and a compound? Two or more. What's a compound? Two different ones. So O2 would be a molecule, carbon monoxide would be a compound. Right? So if it's so if you see them on the exam, like for example O2, that would be a molecule. You see CO2, that would be a compound.
So a compound is basically just more than one molecule, different type, like a different type of molecule.
At least two different ones. Yeah. Yeah. So if it's two of the same, it's a molecule. But if it's so all compounds are molecules, but not all molecules are compounds. Does that make sense? Okay. Cool. Okay. Make sure you know the differences between the synthesis reaction, decomposition, exchange, and reversible. So synthesis reaction is what? A plus B equals
AB.
AB. So it would be decomposition.
AB.
AB equals A plus B, right? So it breaks up. And then what would be an exchange reaction?
Wait, can you repeat that? Sorry.
So,
The decomposition.
decomposition, so here, let me. So synthesis would be and then a decomposition would be, so for example, you take sodium chloride, put it in water, what happens to the sodium chloride?
It dissolves.
It disassociates or breaks up, okay? So what would be an exchange reaction? Huh? Trade. So we got AB plus CD gives you AC plus BD. Right, so synthesis reaction, products are larger than the reactants. And a decomposition, products are smaller than reactants, and then in an exchange reaction, there's no difference in size between the products and the reactants. Huh?
Could you give us an example of the machine?
Like an actual example?
Sodium chloride water for decomposition, is there an example?
Sure, yeah. So for example, if I have sodium hydroxide plus potassium chloride, I will get potassium hydroxide plus sodium chloride. So that would be an example of an exchange reaction. In fact, this is one we do all the time. And then what's an exchange reaction?
What the hell is an exchange?
This is, I'm sorry, not an exchange, a reversible reaction.
it'll be like AE plus CD, and then it'll go to AC plus ED.
Yeah, so we just have these things right here. So, like for example, we'll talk more about, we talked about it a little bit. In your mitochondria, you can take a chemical called pyruvic acid, and you can convert it into lactate, and then you can convert it back from lactate back to pyruvic acid. So easily go back and forth between the two states. Right, so that's an example. A lot of the biochemical reactions that we'll talk about briefly are reversible reactions.
What was reversible again?
Reversible means you can easily go back and forth.
So it's like AB plus CD.
AB plus, yeah, but you can go back and forth. So some reactions, so this one isn't actually a reversible reaction, but there are reactions that are where you can go back and forth. So you can easily convert the product back into the reactant or the reactant back into the product. So a good example, and the one you'll probably see in the exam, is pyruvic acid and lactic acid. So you're exercising really intensely, start to get a burning sensation in your thighs, right? Back off on the intensity of the exercise, what happens? Your muscles will take that lactic acid, convert it back into pyruvic acid, and start using it again for fuel. By the way, lactic acid does not cause muscle soreness. So that's a common misconception. So if anyone tells you that, they're wrong. And if they tell you you don't know what you're talking about, tell them, my professors.
What does cause it?
It's just, the friction, just putting strain on it causes micro tears, which leads to inflammation, which leads to the muscles theoretically getting stronger. Okay, what's a catalyst, guys? Right, something that actually causes the reaction to happen, so it's not happening spontaneously. Because in order for these reactions to happen, right, the two compounds have to be within close proximity to each other. What's an example of a biological catalyst? Or what do we call a biological catalyst, guys? Enzymes. Right, so that's a biological catalyst. So we've got literally tens of thousands of different types of enzymes in our body. The sole purpose of it is to, so for example, converting pyruvic acid into lactic acid. It's a series of multiple reactions where, right, the chemicals literally hand it off to the next thing, which changes it, which hands off another thing, which changes it a little more, hands off to the next thing, changes a little more, and then now it's lactic acid instead of pyruvic acid. So it's what we call enzymatic pathways or cascading pathways. What is an acid and what is a base, and how do we, you want me to keep this up here? What is an acid, what is a base, and what's the metric that we use to denote acidity or basicity of a compound? So acids are ions, specifically anything that, so an acid is anything that releases what into solution? Hydrogen ions, and the base is anything that either takes hydrogens out of solution or adds hydroxyl ions. Guys, remember we talked about this? So instead of writing water as H2O, we can write it as H plus OH negative. So if you have an equal number of hydrogen ions and hydroxyl ions, you would have what we would call neutral, right? Which would be what? What's the scale we use for acidity and basicity?
pH.
pH, which means per hydride. Okay? So 7.0 would be neutral, meaning there's an equal number of hydrogens and hydroxy ions. Anything less than 7 would be what?
Acidic?
Acidic, meaning there's more hydrogen ions than hydroxy ions. Anything above 7 would be basic, right? So the more hydroxy ions you have, the more basic the solution. The more hydrogen ions, the more acidic the solution becomes. What happens as you start to get further and further away from neutral? What's its effect on biological tissues and systems?
More extreme.
It becomes more and more what we call caustic, right? So you get, right, the tomato juice in your eye, right? It's gonna sting, right? But it's not gonna cause any eye damage, right? You get battery acid in your eye, you better flush that out pretty quickly, right? Right? You consume milk of magnesia, which is pretty basic. It's got a pH of about 10.5, right? What would you consume milk of magnesia for?
Constipation.
Heartburn, upset stomach, especially heartburn. It's a good way to neutralize the acidity of your stomach. You accidentally drink some red lye, you better get to emergency room pretty quickly because your esophagus is basically going to be destroyed. So, right. Why is it really, so what is buffers, guys? What do buffers do?
Neutralize acid and bases.
Acids and bases, right? Because our body is basically just a giant sack of proteins. What do we know about proteins? Proteins have a specific three-dimensional shape, right? That's one of the questions that's in there for this one, right? So for proteins, right? So we've got the amino acid sequence, that's right, primary structure. Then we have beta pleating and alpha helix, that's secondary structure. Then we fold it into a unique three-dimensional structure that's called tertiary structure. Right? What happens to a protein if its three-dimensional shape is not maintained? Can the protein do what it's supposed to do anymore? No, it's now what we would call denatured. Right? You can't uncook an egg, right? You can't uncook a steak. Right? It's cooked. So our body has buffers to absorb those acids and bases, mostly acids. So because our body has to stay in a very narrow temperature and pH range, otherwise our proteins will start to denature. So once your core body temperature goes above about 105, 106 degrees, right, bad things start to happen. Your brain will literally start to cook. About 108 degrees Fahrenheit, you're pretty much toast. So 110, you're definitely toast. What happens if your body gets below a certain temperature? Hypothermia, and then frostbite. Your fingers will die, your toes will die, your nose will fall off, your ears will fall off. So what's the difference? So what are the organic compounds? So carbon, hydrogen, oxygen, nitrogen, and sulfur basically are the organic ones. And then everything else would be inorganic. So sodium, potassium, chloride, calcium, magnesium, all of that.
What makes them organic?
Those are the basis for all organic structures, so anything that's living. Right? We are carbon-based life forms. Right? We consume other carbon-based life forms. Right? Whether you are a herbivore, carnivore, or omnivore, you're consuming carbon-based life forms. What's an herbivore, guys?
It's plants.
Only plants. What's an example of an herbivore?
A vegetarian.
Like what? Give me an example of an herbivore.
A gorilla?
Giraffes. So gorillas will actually eat meat, not a whole lot. So
Deer?
giraffes,
Deer?
cows, sheep, right?
Deer?
Deer, right? Take the bird, right? What do we feed cows?
Grass.
Grass and hay, right? They'll be perfectly content with their sheep. Right? What's an omnivore? Wolf. What's an example of an omnivore? Us, we're omnivores, right, for the most part, right? And then there are, what's an example of a carnivore?
Tiger.
Some dinosaurs, T-Rexes, lions, tigers, any of the big cats, right? Wolves, coyotes. Yeah. You know, if you have a pet ocelot and you try to feed it a vegetarian diet, it's gonna not be very good for you. You guys know what an ocelot is?
What is that?
Ocelot? It's a cat. So,
Huh.
yeah, it's like a leopard. Let's see here. Make sure you know the right broad basics about carbohydrates, lipids, and proteins, right? So we got monosaccharides, disaccharides, and polysaccharides. So what's an example of a monosaccharide? Sure. Give me an example of one that's specifically a monosaccharide. There's one that's very important for human physiology. Glucose. Right? Our body needs glucose. Right? A disaccharide would be what? Two sugars together, like sucrose. What's sucrose, guys?
Sugar?
Sucrose is table sugar. Right? And then we've got polysaccharides. What's a polysaccharide, guys? Starch, right? So like bread, pasta, fruits, vegetables, those would be polysaccharides. Okay? So monosaccharide would be the glucose that's flowing through your blood. A disaccharide would be like table sugar. So table sugar is glucose and fructose together. And then polysaccharide would be bread, or corn, or rice, or whatever. Okay? What is the functions of carbohydrates in our body? Basically has one function. Fuel, right? Do we have a essential requirement for carbohydrates?
No.
No, right? Doesn't mean you shouldn't eat carbohydrates, but there's nothing that technically will go wrong with you if you severely limit your carbohydrate intake. So you don't have an actual fundamental need for it. Okay. Lipids and steroids. Okay. So we have lipids, phospholipids, steroids. There are basically two types of lipids. So there are saturated fatty acids and unsaturated fatty acid. What's the difference between a saturated fatty acid and an unsaturated fatty acid? Not enough, right? So there's at least one carbon where there's a double bond, right? So saturated fats tend to be solid or liquid at room temperature.
Liquid.
Solid?
Huh? You guys got a 50-50 shot.
Solid?
Solid, right? So like, for example, right, you got a steak, right? It's got a lot of fat on it. It's called stearic acid. That's the type of fat that's on there. So, monounsaturated fat or unsaturated fatty acids tend to be a
Liquid?
liquid. So olive oil, right? Olive oil is rich in omega-3 fatty acids. It can be liquid at room temperature. Okay. And then proteins, right? We just talked about proteins, right? So proteins are made up of long chains of amino acids. Primary structure would be the specific amino acid chain. Secondary would be that alpha helixes and beta pleating. Tertiary would be it's folded into a specific three-dimensional structure. And then quaternary would be if you got like multiple subunits coming together like you do find in like hemoglobin. Okay. So again, protein is very complicated, right? Only functions in a very narrow temperature and pH range. So for example, you're exercising, doing something really intense, right? Start to get a burning sensation in your muscles. What happens to your ability to produce force in the muscle that's burning? Goes down because as the temperature goes, pH and the temperature goes up from the exertion, it actually starts to cause morphological or physical changes in the contractile proteins of your muscle, forcing you to decrease exercise intensity so you don't just grind your muscles to dust. Right? So you literally have to slow down. You physically cannot do the same amount of work because you're now having a massive increase in heat and change in pH. If it goes on long enough, you'll actually destroy the proteins. Right? But before that, your ability to have contractile faculties decreases. So it's a self-defense mechanism. That's why they're called fatigue toxins or fatigue poisons. Unless you're Captain America, his body doesn't produce those. They never really explain the physiology behind how that works, but apparently Captain America can get that. So. In the comics, he can run something like a 50-second mile, which means you can run at speeds of up to like 70 miles an hour for like extended periods of time. But you mentioned Bucky. All right, RNA and DNA. DNA has how many strands? 2. RNA has got 1, right? So you got A's and T's, C's and G's. And then in RNA, you got A's and T's and C's and U's. It's like 1 or 2 questions about RNA or DNA, so don't really worry about that a whole lot. Questions about chapter 2? Right. Chapter 3. So make sure you know the organelles, general structure and function of the different organelles. Right? Make sure you know about the phospholipid bilayer, how things move through the phospholipid bilayer, diffusion, facilitated diffusion, osmosis, active transport. Give me an example of active transport. What's the example we talked about in lecture for active transport? Sodium, potassium. That's the. You guys ever take another biology class and they talk about active transport? The example is always going to be sodium, potassium. Always going to be sodium. Okay. Endoplasmic reticulum. What's its function? There are 2 types of ER. What are the 2 types of ER, guys? Smooth and rough. Rough produces what? Proteins because of the ribosome, so that's why it's rough, because of the ribosome. So each rough ER produces proteins, smooth ER produces lipids and steroids. Okay. Golgi apparatus, what does it do? Packages up products produced by the ribosome. Right? So it's the shipping and the receiving. The mitochondria is the powerhouse of the cell, right? What does the mitochondria produce?
ATP.
ATP, the energy currency of the body. So mitochondria can take any of the 3 macronutrients, and also including DNA, and convert it into ATP. So carbohydrate, protein, fat, can take all of them, convert them into foods. Lysosomes, what do lysosomes do? They're the garbage disposal, right? So anything that's old, worn out, didn't get made properly, gets into the lysosomes, broken down, and recycled if possible. Peroxisomes do what?
Enzymes.
Detoxify, right?
Yeah.
Oxidizing agents, toxic agents, stuff like that. And then microfilaments and microtubules help give the cell structure. Okay. Centrosomes are involved in what? Mitosis, DNA replication. Cilia do what?
Move stuff.
Pass the cell or move the cell,
Yeah.
right? And then what is a flagella?
It's the tail of the structure.
Right, it's a whip. Remember I talked about the flagellates, right? The religious fanatics that whip themselves, the frenzy with other people. Any questions on any of that stuff? All right. Diffusion, facilitate diffusion, osmosis, active transport. Right? What's an example of diffusion? What's diffusion, guys? O2, right? It's just simple diffusion, right? So you're going from an area of higher concentration to an area of
Lower.
lower. What's facilitate diffusion? What's the difference between diffusion and facilitated diffusion?
From lower to.
So going from high to low, but it's either something that's polar or too big to get across the membrane all by itself, so it needs help. So a good example would be glucose, right? Glucose can only get across when there is insulin, right? So after the body releases insulin, glucose transporters will take the glucose from the higher concentration out of the cell to the lower concentration inside the cell. Right? If you don't have insulin, your cells can't uptake glucose. Your glucose levels will be sky high. Osmosis, what's osmosis, guys? Diffusion of water from an area of higher concentration to an area of lower concentration. Talk about like if you eat something salty, right, your body will soak up more water. And then active transport would be low to high, sodium potassium. What makes active active?
Requires ATP.
It requires ATP because you're going against the gradient. You can float easily downriver, you gotta swim upriver. Make sure you know the phases of the cell cycle. Right. Prophase, metaphase, anaphase, telophase, and cytokinesis. What's happening in prophase?
Preparing.
Huh?
It like prepares it.
DNA is more visible.
So the DNA condenses into chromosomes and then the nuclear envelope disappears, astral rays appear, centromeres appear, centrioles. Metaphase, DNA lines up on the center. Anaphase,
Pulls it to the
DNA
end.
starts to pull apart. Telophase, cleavage furrow starts to appear. And then cytokinesis, my other Bio 160 professor, her name is Korea. Her students got her a shirt one time and it had telophase on the shirt and said, "Stop staring at my cleavage." She would wear it when they were doing mitosis. And just like one or two questions about endocytosis, exocytosis. Right, so endocytosis is taking something into the cell. Exocytosis, spitting it out of the cell. Phagocytosis is what? Literally engulfing it and eating it. So this is what your white blood cells do. Penocytosis is drinking fluids. What is apoptosis? Talk about it. Programmed cell death. Right? So it's a good thing, right? We want cells to die, otherwise they become cancer cells. They are the undead. Questions on chapter 3? Integumentary. Okay? So make sure you know the 3 layers. Epidermis, dermis, and
Hypodermis.
hypodermis or subcutaneous, right? Epidermis has got what type of tissue in it? Stratified squamous, right? So the 5 layers, superficial to deep, are
Corneus.
corneus, lucidum,
Spinosum.
granulosum, spinosum, basale. Come, let's get sunburned. Okay, remember that acronym. Corneum, lucidum, granulosum, spinosum, basale. Which is the only alive and mitotically active layer? Basale. Okay. Which layer is melanin found in? Spinosum, and then granulosum is where you make keratin. So what's the function of keratinization? What does keratin do? Water briefs the skin, right? And then melanin does what? Yeah, so it's pigmentation, helps absorb ultraviolet radiation, which is why if your direct ancestors are from a very sunny place like Equatorial Africa, you have very dark skin. If your immediate ancestors are from closer to the polar regions, you're gonna have lighter skin. Nails and hair, right? Basically, they're just what? Highly keratinized skin cells is basically what they are. What's the function of a sebaceous gland?
Water, like produce water.
produces oil. Sebaceous glands produce sebum, which the oil lubricates and antimicrobial. Okay. Rector pili muscle does what? Cause your hair stands on end. Make sure you know the two types of melanin. So eumelanin is what color? There's pretty much two colors. Perfect. Eumelanin is brown. Pheomelanin is
Orange.
orange. Reddish yellow.
What was the name of that one?
Pheomelanin. So if you're brunette, you have eumelanin. If you're redheaded, you've got pheomelanin. How about like very light haired blondes? Like Nordic people. What's going on there? They just don't have very much melanin. So if you're very fair skinned, you just don't have a whole lot of melanin. Like the Irish. So if you ever see Natalie at the beach, cover it up. Big hat on. Looking like powder. Okay. Two types of sweat glands, epicrine and acrine. Epicrine are found where?
On your skin, general.
Everywhere, and then acrine are found.
More in your armpits and groin.
Right, they produce musk or scent. What are the three ways in which we can regulate body temperature?
Sweating.
So evaporation, convection, and conduction. What's convection, guys? Transfer through the air. So if the air is cooler than ambient body temperature, what happens? We lose heat to the air around us. All right, what's conduction?
Physical contact.
Touching something that, right? If you touch something that's colder than you, what's happening? Heat's going from you to that object. And then evaporation is sweating. Yeah. When we talked about, right, if you're in the southern United States in August, right, very little opportunity to have any amount of heat loss because it's hot and it's humid, right? So you're not having through convection or through evaporation. Make sure you know the three levels of burns. Don't really worry about the inflammatory process. Like one question. What are the three levels of burns, guys? What's the first degree burn?
Just like your,
It's burning the epidermis, right? Second degree burn is epidermis and dermis, and a third degree burn is all three layers. Make sure you know the different types of bones. So we got long bones, short bones, flat bones, irregular bones, and sesamoid bones. So know one example of each. So humerus would be a long bone. Skull would be a
short bone.
flat bone. Wrist would be a short bone. Vertebrae would be a
Regular.
irregular, and then your patella would be a
Sesamoid.
sesamoid bone, right? So there might be an example, right? So there might be a question like, which of the following is a sesamoid bone, or which of the following is a flat bone, or which of the following is a long bone, or the humerus is a, right, sesamoid bone, long bone, short bone. Where do we find, especially in a long bone, where do we find spongy bone?
In the middle?
Find it on the end, right, the epiphyseal region, and then we find compact bone in the shaft or diaphyses region. Okay. Intramembranous versus intracondyle. What bones are made for intramembranous? Bones of the face and skull. Everything else is intracondyle. What's the epiphyseal plate, guys? also known as your,
Sternum.
nope, growth plates. It's one of the ways, so like, for example, when they, when we get mummies, right, we x-ray them. So like when we say, we think King Tut was 16 when he died, part of why we think he was 16, number one, looking at the records. Number two, when we look at his x-rays, we can still see growth plates in his bones. So he hadn't reached physical maturity yet, so, which is defined as your growth plates that are closed. For girls, it's somewhere between 14 and 16. For boys, somewhere between 18 and 19. Funny how we're still obsessed with so bone growth, repair. So osteoclast, build bone. Osteoclasts, break bone down. Osteocytes, maintain bone. So what do we call that? The constant breaking down and rebuilding of bone. We call that
Osteoclast.
bone. Well, it's done by osteoclasts and osteoblasts. That's called bone remodeling. Remember we talked about, right? So as we get older, right, you have to do resistance training, right? Weight bearing on your bones, otherwise your bones will atrophy and you'll start to get osteoporosis. Talked about why like the Amish don't get it.
So what is it called?
Bone remodeling. Make sure you know the difference between the axial and appendicular. So what bones would be the axial skeleton? Skull, hyoid, vertebrae, and sacrum and coccyx. Everything else would be appendicular, which is what we're going to cover today or this week in lab. All right, 3 types of joints: fibrous, cartilaginous, and synovial. Give me an example of a fibrous joint. Fibrous or sutural joint. Bones of the skull, right? So for example, your frontal sagittal joint. Huh? So any of the bones in your skull, that's going to be a sutural or fibrous joint. Right? How do you name a joint, guys? You take the 2 bones, right? So frontal bone,
Parietal.
sagittal bone, right? Join together right there where the coronal suture is. Cartilaginous joint. Sternum. What else? Pubic symphysis, vertebrae. Those are the 3 examples we talked about. And then what's the last one?
Synovial.
Synovial joint. What's a synovial joint? Give me an example of a synovial joint. Huh? Elbow, shoulder,
Knee.
ankle, knee, hip. Okay, so what's unique with what's going on in a suture or a synovial joint? Got a capsule, right? Synovial fluid, cartilage on the ends of the bones. Right, so then we got the different types of synovial joints. Ball and socket. Name a ball and socket joint.
Shoulder.
Shoulder, hip. Okay. Condylar joint. You guys show for the exam. You guys don't have
The up.
scantrons, right? Hands start flying. Knuckles. Cowboy. Plane joint. Wrists and ankles. Hinge joint.
Your jaw.
Elbows and knees. Okay. And then the saddle joint. We talked about the saddle joint. Thumb. So it allows us to do opposition, right? Which is something only primates can do. And otters.
Oh, I love otters.
Everybody loves otters.
I'm sorry.
They float around, hold on to each other's hands. Right? Joint movement, okay? Flexion. What's flexion, guys? How would you describe flexion? Huh? What does going down mean? Flexion of what? What am I flexing when I bend forward? Flexion of your spine, right? So flexion is decrease of an angle, right? So this would be flexion of my spine, right? Or I can flex my hip. I flex my hip joint, right? What would be extension? If flexion is decrease of an angle, extension would be, so this would be back extension, this would be hip extension, okay? Flexion of my elbow joint, extension of my elbow joint. Flexion of my shoulder joint, extension of my shoulder joint. Flexion of my wrist, extension of my wrist. Dorsiflexion and plantar flexion. Dorsiflexion is toes up or toes down. Toes up. Plantar flexion is, remember we talked about, right, you're pushing seeds into the ground, right, when you're planting, right? Abduction and adduction. Abduction is what?
Is it opening?
Huh?
Opening?
Opening what?
Like hips?
What would be hip opening?
Further away.
Further away from what?
The center?
From the midline, right? Movement away from the midline. So this would be abduction of my humerus, adduction of my humerus. So if I wanted to abduct my leg out to the side, adduction. So if I'm doing jumping jacks, that would be abduction, adduction. Opening, that would be internal and external rotation. Right? So you're externally rotating your femur, internally rotating your femur. Okay. Rotation versus circumduction. What's the difference? This is rotation. That's circumduction. Okay. Pronation versus supination. Supination is, remember I told you guys? You're holding a cup of soup. That's supination. Before most of you guys were born, there was a big hit song in the 90s where there was a lot of pronating and supinating in the song, in the dance. You guys know what song I'm talking about?
Macarena?
Yeah.
Eversion and inversion. So eversion is rolling on the outside of your foot. Eversion would be rolling on the inside of your foot. Okay. Protraction and retraction. So protraction of my jaw, retraction of my jaw. Right. Elevation and depression. Elevate my scapula. Depress my scapula. We feel like we got this? All right, we'll take a break. We'll do our quiz, and then we're going to do Jeopardy, where we're going to cover a lot of this stuff. And we're going to break you guys up into teams for extra credit points.